All right, so now what we're going to look at is we're going to look at our first set of rules for finding derivatives. So we don't want to actually utilize the definition of a derivative every time we want to find a derivative. There's got to be easier ways, and it turns out there are a ton of easier ways. And chapter 3 is all about those easier ways and their applications. The first one that we're going to look at, the most basic one, and the one that, you got to master tonight, right? Or tomorrow night after we get done with the lecture, like the thing that you want to you need to zone in on is this whole idea of the power rule. Okay, the power rule and some affiliated ones, like the derivative of a constant and the derivative of what we call the identity function. Okay, so let's take a look at them and let's see if we can first kind of get a sense of why the rules are the way that they are without kind of going into all the proof. Okay, so let's first start out with f of x equals 5, and let's use the definition of a derivative to find uh, the derivative of f of x equals 5. So f prime of x is going to equal then the limit as h approaches 0 of f of x plus h minus f of x all over h, right? That's the definition of a derivative. Well, in the case of a constant function, f of x plus h is actually 5, and f of x is also 5 because it's constant. It doesn't change. So we got 5 minus 5 over h, and that's just the limit as h approaches 0 of 0 over h, and so that's simply that's 0. We don't even need to take that limit. It's 0. Okay? Cool. Huh. Now, since the fact of the matter is that this is a constant function, does it really matter that it's a 5? Nah, it doesn't really matter that it's a 5. It could be any number, really, as long as it's a constant. We're going to end up with 0 as its derivative. That's going to turn out to be the rule. The derivative of a constant function is going to be 0. Cool. Now what about x? That's the next simplest function, right? So let's take the limit as h approaches 0, and this will be x plus h, right? Minus x all over h. And this then is going to be the limit as h approaches 0 of just h over h, which is just the limit as h approaches 0 of 1, which is simply 1. Ooh. So the derivative of f of x equals x is just 1. Nice. That's cool. I like that. Okay, great. What about like if I multiplied x by a scalar? What then? What would happen then? Well, let's see what we get. So we've got the limit as, and in this case it's going to be 7 times x plus h minus 7x all over h, and that's as h goes to 0. And what you see now is you can actually factor out that 7. So this is now 7 times x plus h minus h. Okay, so this is the limit as h approaches 0 over h. And if you remember one of our limit rules, if this is just, that's a constant, right? Okay, so we could just pull that out. This is, or excuse me, minus x, not h. This is just going to be 7, right, times the limit as h approaches 0 of h over h, which equals 1. Which actually equals, excuse me, it's 7 times 1. So that's 7. Huh. Well, f of x equals x had a derivative of 1. 7x has a derivative of 7. Maybe that comes in handy. Okay. What happens when we multiply by a scalar, right? So this is multiplication by a scalar. Let's think about that. What's going to happen there? Well, let's take a look at another couple and see if we can kind of derive some rules. How about f of x equals x squared? Okay, well, let's try it out, right? We want the limit as h approaches 0 of x plus h squared minus x squared over h. And if I FOIL that out, I'm going to get the limit as h approaches 0 of, and this is going to be x squared plus 2xh plus h squared minus x squared over h. And notice that my x squareds cancel out, right? We've probably seen that quite a lot, that those things that don't have the h in them, they should cancel if we actually have a derivative. So this is going to end up equaling then the limit as h approaches 0 of, and this will be 2xh plus h squared over h. And so that's going to then be the limit as h approaches 0 of 2x plus h, which is just 2x. Okay, that's cool. All right. How about x cubed? Okay, let's see. So we got the limit as h approaches 0 of x plus h squared, or x plus h cubed now, minus x cubed over h. Now you might have to actually pause the video for a second and actually go out and FOIL this out. But it's going to end up being the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. Now you can imagine as we get to like x to the 4th, x to the 5th, this gets a little hairy to do. Really, it really would make a huge difference for us to have a simpler way of going about this. Hence why we're going to get to the power rule. So this is going to then equal, right? My x cubes are going to go away. This is going to be the limit as h approaches 0 of 3x squared h plus 3xh squared plus h cubed over h. And that's going to end up equaling the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Okay, which is just equal to 3x squared. So now, if we take a look at this, here's my derivative of x squared, and here's my derivative of x cubed, right? If you're kind of into patterns, which if you're into math, you're kind of into patterns, right? What we look at it, we'll see, okay, well, all right, this was x squared, now I got a 2 in front of it, and this was x cubed, and now I got a 3 in front of it. And this was x squared, and this is now x to the 1. This was x cubed, and this is now x squared, right? Well, that's the power rule in a nutshell, right? This power becomes the coefficient in front of x squared, or in front of the x, and then we drop the power by 1, okay? So we're going to see that, that rule in just a second, okay? Notice, right? 3 comes in front, right? And then we drop this 3, it becomes a 2. There it is. So let's start with our derivative rules. And I should state, memorize. You need to know these by heart, okay? Everybody who does any calculus does. I might as well tell you right up front, there's no way around memorizing them. You must know them, okay? So we'll start out with what's the derivative of a constant. So d dx of c equals 0. There it is. That's what we see. C is the constant. We see that the derivative of a constant is always 0. That was not so hard to remember, right? Probably already got that one memorized. Awesome. What about the derivative of the identity function? And before I go on, I want to make sure that you know this thing here, this d dx, that stands for like our f prime, okay? It's the derivative, okay? So that's how we write the derivative with respect to x is what we say. The derivative with respect to x of x is always going to equal 1. We saw that one a little earlier too. The derivative of x to the n, this is our power rule, okay? Where we bring the n out, right? And then we subtract 1 from it, right? So we have n x to the n minus 1. And then another one that we have, this constant multiple rule, okay? All you need to know is that what happens here is that you can take if you take the derivative of a constant times a function, it's the same thing as taking the derivative of the function and then multiplying it by the constant. We can multiply by the constant afterwards. And what I'm going to do is I'm going to show you some examples of doing that. And then this sum or difference rule. And this one is crucial. This is very important. What this basically says is that you can either take the derivative, you can add two functions together and then take the derivative, or you can take the derivative of the two functions separately and then add or subtract them. Okay, and that's going to be really important for us working with polynomials. All right, that's the sum or difference rule, and I'm going to demonstrate that in more depth in just a moment. Okay, so these are memorized ones. Go ahead, pause it, write them all down. Okay, they're also in your book, but you want to make sure you write them down. Really helps to remember them, and then we're going to use them in order to do some examples. So let's say we want to find the derivative of the function f of x equals 7x to the 4th plus x cubed minus 5x squared plus 2x minus 6. Okay? So when I want to do that, what I'm going to do is I'm going to say, okay, let's take f prime of x, and I'm going to then separate them out using that sum and difference rule. So that's going to be d dx of 7x to the 4th plus the derivative of x cubed minus the derivative of 5x squared plus the derivative of 2x minus the derivative of 6. Then, okay, I'm just going to think about this from the perspective of I'm going to bring out the constants. Okay, so this is going to then equal, and by the way, by the time you get really good at this, you're not going to like bring out the constants. You're not going to do 8 steps for this. You're just going to do it all at once. Okay, it's going to be like, oh, clearly saw you used the power rule, right? And you brought out your constants, no problem. But for right now, just to demonstrate what we're doing, I'm going to bring out all my constants. I'm going to show you that we're taking derivatives one at a time. Okay, so this is now 7 d dx of x to the fourth plus d dx of x cubed, it doesn't have any constants in there, minus 5, the derivative of x squared, plus 2 times the derivative of x, minus, and this is just going to be 0, right? The derivative of 6 is 0 because it's constant. Okay, that's a constant. 0. So now I'm going to use the power rule to find the derivative of x to the fourth. So this is going to be 7 times 4, right? We'll bring out the 4x, and then we'll subtract 1 from 4, 4x cubed. Plus, do the same thing, right? 3, that's our power, x, and we'll drop the power by 1, 3x squared. Minus 5, okay, bring the 2 out, times 2, x, and then we'll drop it by 1, x to the 1, which is just x. Plus, and then the derivative of x, that identity function, is just 2 times 1. Okay, now we'll simplify. This gives me 28 x cubed plus 3 x squared minus 10x plus 2. And there is my derivative. So just to reiterate what I did was I broke up the derivative, okay, into its component parts, right? Like I said, when you start getting really good at these, you don't have to like go out and write them all out as d dx, blah, 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 right? You'll just kind of like do it one at a time, but you need to understand that this is something that you can do. Like this is an option, right? That you can break them up and then find their derivatives individually, okay? Then I pulled out my constant, another one, right? We just pulled out the constant, okay? And then I used the power rule, okay, in order to simplify my derivatives, right? In there I also had the constant function there, that's 0, right? And then finally I simplified. Easy peasy. Maybe not so easy, okay? Practice. You practice this, you'll master it. You need to master it because you just need to. It's just got to do it. Everybody can do it. There it is. Now, this one, f of x equals 1/2 x to the fourth minus 5x cubed plus 1/4 x squared minus 9. So we'll find f prime of x, so the derivative, and that's going to be, and again, we're just going to break it up using the sum and difference rule. d dx of 1/2 x to the fourth minus d dx of 5x cubed plus d dx of 1/4 x squared minus d dx of 9. Okay? All right? So we broke them all up. Now what we're going to do is we're going to pull out our constants, or our scalars. 1/2 d dx x to the fourth minus 5 times the derivative of x cubed plus 1/4 times the derivative of x squared minus, and this is a constant function, so it's going to be 0. Okay? Now we're going to use our power rule. So it'll be 1/2, right, times 4x cubed, right? 4 comes out. We subtract 1 from the power. There it is, 4x cubed. Minus 5, and this will be times 3x squared, again using the power rule, plus 1/4 times 2x to the 1, and then we're just going to go in and we're going to simplify. This will be 2x cubed minus 15x squared plus 1/2 x. And that is our derivative. So this is the power rule, okay? This is how we use the power rule. This is like basically all of the values that we can get from the power rule. Also remember that the derivative of a constant function is 0, okay? So go in here, practice this. This just takes practice, right? You do it over and over and over again until you never forget it. It becomes ingrained in your consciousness. Literally, engineers can do this stuff in there with their eyes closed. Okay? It just takes practice. Practice, practice, practice. All right, this ends the lesson.